Hey guys, lesson 3.4, using the quadratic formula. This lesson should seem a little easy because you guys learned about the quadratic formula in Algebra 1. We're just going to add a little bit to it now that we've learned about imaginary numbers. So the quadratic formula is right here for you to use, where a, b, and c are real numbers and a cannot equal 0. And just a reminder, where do you get those a, b, c values? From the quadratic function. Notice that this is set equal to 0. So that is one of the first things that you are going to check for. You're going to make sure that your equations are set equal to 0 before you start working the quadratic formula. So let's get started. Solving an equation with two real solutions. So remember, when we solve quadratic equations, we are finding where the graph crosses the x-axis. We're finding the x-intercepts. So first step, set equal to 0. All right, that's what I just said, set equal to 0. This one is not set equal to 0, so we are going to move the 5 to the other side. So once it is moved to the other side, then that makes it negative. So we have x squared plus 3x minus 5 equals 0. So it may be helpful for you to name or list your ABC values. So I'm going to do that. It is not something you have to do, just maybe something that you would like to do. Remember, if there is no coefficient or no number in front of your variable, if there is none, there is 1. Because remember, a cannot be 0. So in this case, our a value is 1, our b value is 3, and our c value is negative 5. So notice I took the negative with it. So if your b term or your a term is negative, you need to also use that negative. All right, now I'm just going to put it into this formula. All right, so the most common mistake, something to be careful for, is if your b term is negative. If your b term is negative, remember that you're squaring the negative as well. So that's probably the most common mistake. People forget to square the negative. In this case, it's positive, so we are okay. All right, so we're going to just work this out one step at a time. We're going to simplify it one step at a time. So I'm going to start with 3 squared. 3 squared is equal to 9. Then I'm going to treat this as a negative. You do the way that's most comfortable for you, but I like to go ahead and just look at this 4 as a negative instead of all of this being subtracted. So negative 4 times 1 gives you negative 4. Negative 4 times negative 5 gives you positive 20. And then all over 2 times 1, which is 2. All right, next up, we're going to add our 9 and 20 together. So now we have negative 3 plus or minus the square root of 29 over 2. So here is where, if we have a factor that is a perfect square of 29, then we would simplify. In this case, we do not. We do not have a factor of 29 that is a perfect square, so we are not going to simplify. So we now know our solutions. All right, these solutions are, you should have 2. X equals negative 3 plus the square root of 29 over 2. And we have x equals negative 3 minus the square root of 29 over 2. So this part here is your final answer. All right, those are your final answers. All right, so this is how it will look when you have two real solutions. So this means that we could actually find these points on the graph, and our graph would cross there. So let's look at what happens when you only have one solution, one real solution. Let's see how that is different. So again, our first step is to set the equation equal to 0. So this has a little bit more going on So I'm going to actually show a little more work than just moving. So we're going to subtract 12x from here, which means we also need to subtract 12x from there. To move the minus 4, we're going to add 4. I'm just going to put it off to the side because I don't have a 4 to add. So why am I doing this? Because that means that this side over here will now equal 0. Because 12x minus 12x, oh, got to put the x there. 12x minus 12x is 0. Negative 4 plus 4 is 0. So now I'm going to bring down this side. We have a 4. Negative 8 minus 12 gives us negative 20x, and then we did not do anything with the 25x squared, so that just stays the same. All right, now you should be able to put this in the quadratic formula. I would like for you to pause the video and give the quadratic formula part a try. Go as far as you can, and then unpause the video and see how well you did or what you may need a little more help on. So please pause the video now. To give this a try. Your A value is 25, your B value is negative 20, and your C value is 4. I hope that when you squared this, you remembered to square the negative as well. So if you got different ABC values and you did not try to put them into the quadratic formula, please pause now and give that a try. All right, so this is what it should look like when you have it set up into the quadratic formula. Now you have negative 20, so this is another common mistake. When your B value is negative, don't forget it because the formula is negative B. So this becomes 20 plus or minus the square root. So negative 20 times negative 20 is positive 400 minus 4 times 25 times 4. So 4 times 25 is 100. 100 times 4 is 400. And then all over 50. So then we can simplify this a little further. We have positive 20 plus or minus 400 minus 400 gives us 0. So anytime you have 0 in your radical, that means you are only going to have one solution because the square root of 0 is simply 0. So this essentially becomes 20 plus or minus 0 over 50. Well, what happens if you add or subtract 0 to 20? You're just going to get 20. So you have two solutions. Let's simplify just one more step. So now we're down to 20 over 50. 20 over 50. And we can simplify by tens, right? So we can simplify by tens and be left with 2/5. So the solution is 2/5. So what does that mean? That means your graph only crosses the x-axis one time. All right, it only crosses it one time. Most of the time when it only crosses it one time, that means that's your vertex. All right, moving on to example 3. All right, solving an equation with imaginary solutions. So, why does it become imaginary? So what it means is it's still an equation. It still is a graph. You can still graph it. The thing is that you will not see it cross the x-axis. So it's either going to be all in the positive section of the graph or all in the negative section of the graph. So because in the past you couldn't find the square root of a negative number, you would just say no solution. Well, now we have learned that we can, so we're going to find that solution. We're going to use our imaginary numbers. All right, so again, we need to start off by setting it equal to 0, so I'm going to move that 13 to the left. And that is going to give me negative x squared plus 4x minus 13 equals 0. Again, I would like for you to practice, because all this is still doing the quadratic formula. It's just we're going to have different solutions. So I would like for you to give this a try, plug in your ABC value, do as much as you can, and then unpause the video and see how well you did or if you need some more help. All right, so hopefully you gave this a try. You plugged in your ABC values and got this. And if you simplified it already, you can skip through the next few seconds. I'm going to simplify it with you guys. It's completely up to you. All right, so we got 4 squared, which is 16. And then we have negative times a negative times a negative. So I know that a negative times a negative times a negative is going to give me a negative. And now I can just focus on 4 times 1 times 3. So 4 times 1 is 4. 4 times 3 is... I think I may have said 4 times 3. If I did, I apologize. It was 4 times 13. And that gives us 52. And that's all over negative 2. So again, continuing on, we're going to take our 16, subtract our 52. So we're going to get x is equal to negative 4 plus or minus the square root of negative 36, because that's what 16 minus 52 is, all over negative 2. So now I can find the square root of this. First, 36 is a perfect square, and my negative, I learned in lesson 2 that the negative square root becomes an I. So I can now rewrite this as negative 4 plus or minus 6i over negative 2. All right, and because all of my number parts are divisible by 2, I can actually simplify this. And so I can separate each part and divide them by negative 2. So I'm going to show you that step just so I don't confuse anyone on how I'm doing this. All right, so we have negative divided by negative gives us a positive. And then this doesn't matter because it's going to stay plus or minus. So really this negative doesn't affect our second part. And then 6 divided by 2 is 3. So we still have 2 solutions. They are just now imaginary. And they are 2 plus 3i, well, x equals, and x equals 2 minus 3i. So those are our 2 solutions, 2 imaginary solutions. So we found the solutions. All it means as far as the graph goes is that you won't see them actually cross the x-axis. Okay, well, lunchtime is almost over, so I've got to stop this video for my next class. So I will have to make a second part to finish this up after school. All right, so I will see you in the next video.